Welcome to this session on accelerating data-driven circular economy initiatives with AWS. My name is Jenna Liner, and I am part of the AWS sustainability team, predominantly working with customers across our Asia-Pacific region. I'm going to be joined in the conversation a bit later on by Mr. Kusum Oh, who leads the AI innovation team at SK ecoplant, who's an AWS customer. Today, we're going to start with the fundamentals. What do we mean by circularity? What does it mean in the broader context of sustainability? And why is transitioning to a circular economy important? Then we're going to look at how organizations can get started on the transition by first adopting circular economy principles, and we'll take a look at those being adopted by AWS. Finally, I'll consider that we need to be moving through the transition at pace and how digital technologies can help accelerate the outcomes of circular economy initiatives. I am then going to welcome Mr. Kusum Oh. He will introduce SK ecoplant and take you through an example of where his team has leveraged technology to accelerate initiatives in their own operations. So, for a while now, the term sustainability and circularity have been gaining momentum in more mainstream political and social dialogue. Circularity is not a new term, but the conversation on how to transition to a circular economy has now entered corporate boardrooms and government strategies around the world. Where an organization is striving to be more sustainable, they are more than likely trying to make their operations more circular as well. The UN has defined sustainability to mean meeting the needs of the present without compromising the ability for future generations to meet their own needs. In order to do this, however, you have to acknowledge that sustainability takes a systems-level approach. It considers the interrelationships between environmental, social, and economic factors, how they interact, and how they can be balanced. You can't just focus on environmental aspects, for example. This may shift risks elsewhere in the system, resulting in unsustainable outcomes. Instead, you must strive to understand all aspects and their impacts and ensure that they are balanced. For example, think about a toothbrush, where the handle is made from wood instead of plastic. Seems sustainable, but you really need to consider the often unquantified and unaccounted for sustainability-related impacts that span the entire process that led that toothbrush to your hand before you can call it sustainable. That is to say that you need to look at all of the environmental, social, and economic factors at play. Then the concept of circularity, when a product or a resource is renewed or regenerated rather than wasted. When a resource is in a circular economy, it is subsequently reused in a way that allows it to go back into a new life cycle or supply chain. Think about that same toothbrush with the wooden handle. If that handle has been made by timber offcuts, that material is being reused in a new supply chain instead of being discarded as waste. Understanding these two concepts of circularity and sustainability, you can see that achieving circularity on its own does not necessarily mean something is sustainable, but that circularity is one method of achieving sustainability. So, at Amazon, we are committed to being net zero across our business by 2040, and circularity plays an important part in helping us achieve this goal. It is a priority across all areas of the business of Amazon's, including AWS data centers. We want to ensure circularity is embedded in our operations because we know it is one way that will help us build a more sustainable business. One example of where we're doing this in AWS data centers is using cleaner fuel for our backup generators. Starting this year, we have implemented hydrotreated vegetable oil, or HVO, in data centers in Ireland and Sweden. HVO is renewable, non-toxic fuel that can be made from vegetable or plant oil. Given this, HVO is apt for use in a circular economy. Also, according to one of our fuel suppliers, using HVO is expected to reduce the CO2 emissions by up to 90% over the fuel's life cycle when compared with diesel from fossil fuel. So in the future, we aim to use HVO across all of our data center sites in Europe, and we're looking to expand that globally. Another example is with our water usage in our data centers. Last year, here at reInvent, we talked to you about what it means to be water positive by 2030. That is, that we are going to return more water to the communities than what we consume in our direct operations. Water is the single most important shared resource across all aspects of our lives. And it's not only a resource, it's a nutrient carrier, and it's even a source of energy. The long-standing approach of using water and then disposing of it straight away is no longer viable. Too many urban centres around the world are vulnerable to declining and variable water levels for us not to do anything. So, at AWS, to become water positive, we prioritise sustainable water sources, such as recycled water, wherever possible. In fact, recycled water is used for cooling in 20 of our AWS data centers around the world. This includes data centers in California, Virginia, and Singapore, where these data centers are using recycled wastewater instead of drinking water to make sure that higher quality water is available for the communities. Also, once we've maximized the use of water in our data centers, we find ways to return it to the community. In Oregon, for example, 96% of the cooling water from our data centers is supplied to local farmers who then use that to grow crops like corn. This is circularity, taking something that's left over and regenerating it back into nature via the farmers. So, according to a 2019 European study, each year 90 billion tonne of primary materials is extracted and used, but only 9% is then recycled. What is more worrying is that more recent reports suggest that the situation is only getting worse, and that percentage is slipping back to 7%. This means the majority of our global economy is a linear one, where raw materials are taken and used to make products, then the products or its materials go straight into landfill, and the process starts back at the beginning once again. Instead, we need to be transitioning to a circular economy, one where we start to see the reduction of finite materials and waste created across end-to-end supply chains. So to do so, we need to be reversing linear trends and moving away from the current take, make, waste mentality that is sapping natural resources and dangerously warming the planet. But it does go further than just recycling. In a circular economy, for example, the product is designed to use recycled content. And then once the user is finished with the product, its components are returned back into the supply chain instead of going back into landfill. And we can all do this, right? Hands up, who has kids? Keep your hands up if you're happy to be here at reInvent without them. I'm kidding, hands down. When I'm not working with AWS customers or here talking to you at reInvent, I am a mum to my young son. Now I'm learning, kids, they grow up fast, and I'm constantly trying to think of new ways to engage him and give him space to grow. So I often find myself in scrapyards, finding material that is no longer in use, and rightly or wrongly, I build toys and furniture for him to use. Please don't judge the quality. To my son's dad, this is how we're saving the family money. But this is a really simple example of how I'm bringing circularity into my own home, using materials that would otherwise have been wasted. When my son is done with the toy or the shelves that I've built, I can then pass that along to a new home, keeping that material out of landfill once again. So as individuals, we can all do our part, but we need to build circular operations in business. This is where the opportunity to transition is at scale, and it allows us at a faster pace to decouple economic activity from the consumption of finite resources. Look at how the World Economic Forum has defined circular economy. It will not come around by accident. There needs to be intent, and the intent needs to start at the design phase. So if we think about what a circular economy is then, it's really based on 3 principles. Design out waste, keep products and materials in use for as long as possible, and then regenerate natural systems. Adopting these 3 principles is really the first step that any organization can take on the transition. And at AWS, we embrace these 3 circular economy principles for our server racks. The first principle is design. In this stage, we eliminate excess materials such as steel or plastic, increased recycled and bio-based content, and plan for repair, reuse, and recycling from the beginning. Then, we want to ensure our equipment can be used as long as possible. In 2022, AWS actually extended the life of our server racks from 4 years to 5, and our networking equipment from 5 years to 6. In addition, we have a robust maintenance and repair program designed to increase component reuse and further reduce the waste across our supply chain. There is a trade-off in this step. We want to extend the useful life of our hardware, but at the same time balance any efficiency loss by not replacing that hardware with newer, more energy-efficient chips. We strike that right balance by being focused on using equipment for as long as operationally efficient. The final principle is recover. When it's time for our server racks to be decommissioned, sanitized equipment is routed to our reverse logistics hubs that AWS uses. So I'm going to play a short video for you now that allows you to have a look a little bit more behind the scenes at those global reverse logistics programs.
Right now, we are in our failure analysis testing lab, which is a part of our AWS reverse logistics processes for North America.
In the failure analysis lab, we evaluate, repair, and test components from retired server racks.
All of the hardware that it takes to power our data centers is now able to come to our AWS reverse logistics hubs to be able to be repaired and reused.
Our goal is to extend the life of our existing hardware whenever possible. When the hardware arrives, it's in AWS racks.
We apply really the same high level of care and data security as we do when the hardware is active in production in our data centers. All of these server racks we receive are sanitized of customer data so they can be demanufactured. During this process, the servers are disassembled so that we can access the components we might be able to repair and reuse.
And then we will test everything from switches,
Power supply units,
DIMMs,
graphics processing units,
and then optics.
For our Nitro cards, after they go through the demanufacturing process, they are eligible for our failure analysis testing process.
When a card gets to the FA lab, the first thing we do is a visual inspection.
We do have a repair process that allows us to repair some of the components on the card to allow us to further test the card.
We put the repaired cards in testing rigs that simulate the environment of a data center.
And then we have a series of software scripts that work in conjunction with the hardware to determine if the card will perform to the same high quality standards just as a new card from manufacturing. All of our testing process is supported by Amazon's Annapurna Labs teams to determine what needs changed, adjusted, or modified into the new card manufacturing.
As a final step, the functioning cards are returned to inventory so they can be reused in one of our data centers.
This process would not be possible without all of the people behind the scenes working together to solve these really interesting challenges that have not been solved on this scale before.
The work that we do here is creating a more sustainable future for our data centers, and we're really proud to be a part of that.
We have a lot of pride in the work that we do and knowing that there's still a lot of useful life in the products that we touch to support all of the services that our AWS data centers support for customers.
So in that example, there was a piece about providing feedback to the team that originally designed the equipment. And I think that's an example of where digital technologies can help to accelerate a step like that when it is at scale, by allowing teams that are running these type of initiatives to execute them using more near real-time data. We know the window to act and prevent the devastating impacts of climate change is closing rapidly. So finding ways like this to accelerate these initiatives through the use of technology is crucial. But when I'm out in the field talking to customers, and especially IT teams, they balk at the topic of sustainability, and even more so circularity. But I want each of you in this room to consider these topics to be just another business use case. And I would guess all of you in this room, with your expertise in working with AWS technologies, can help to accelerate outcomes. You can support your operations to be more circular, and therefore your organizations to be more sustainable through the use of our technology. So let's look at some examples of this. That is, how digital technologies can accelerate circular economy initiatives. First up, IoT, the extension of the digital world into the physical one. IoT is a network of physical objects linked by sensors, software, and the internet for the purpose of exchanging data. Sensors can collect data about the behavior of processes like conditions such as temperature or moisture. There are so many potential use cases in this space, given that machine-to-machine communications from IoT devices can generate more data than human-to-human communications. IoT technology is crucial in a circular system because it enables the creation and the processing of data to give organizations better visibility into real-time material flows and their supply chain. Then, what do you do with the data? Data can help to establish baselines for sustainability use cases, and we are seeing many customers do this for carbon, for example, as part of their decarbonization goals. However, thinking about baselining when it comes to transitioning to a circular economy is nascent, as is assessing levers and measuring outcomes, which is still patchy and not comprehensively understood. So foundational data projects could help to identify and close a lot of these gaps by bringing siloed data into a circular economy data lake. Then organizations can use that to establish baseline and set goals to make incremental progress or improvements against it. Data can also be a powerful insight as to trends, roadblocks, and enable organizations to track KPIs as to the effectiveness of their initiatives implemented. Examples of KPIs in this space could be the amount of waste generated through the process, or you could assess how much water you had planned to use versus how much you are actually using in downstream processes. The last one that I want to touch on is AI/ML. These technologies can help to identify patterns and plug data gaps as well. Or, together with predictive analytics and simulations, it can forecast future changes to that established baseline that you are able to make. AI and ML algorithms can monitor and optimize energy use in real time, identify inefficient processes, and recommend changes to reduce waste, for example. We can use machine learning to analyze trends and detect patterns that lead to better decision-making. IoT, when combined with AI, could allow for better monitoring and management of resources. According to the UN Environmental Programme, data analysis for innovation, forecasting, and optimization is the most significant application of AI when it comes to circular economy. So one example of how these technologies are actually working in practice is with an AWS customer, Risocar, one of the largest buyers and sellers of used vehicles in France. Using a combination of real-world and synthetic data, the customer built a ML algorithm using Amazon SageMaker to analyze images and determine the cost of refurbishment with exceptional accuracy. By accurately detecting vehicle damage and assessing the refurbishment needs on AWS, Risocar's trade-in processes are faster and more efficient. This ability actually extended the lifespan of selected cars by up to 5 years, which helped reduce landfill waste and promoted sustainability within the automotive industry. So at AWS, we are also using digital technologies to accelerate outcomes of our own initiatives. One example is improving our water efficiency. So in the data center space, we need water to cool our data centers, and when doing so, we strive to use that water in the most efficient way. In 2022, AWS's global water use efficiency metric was 0.19 litres of water per kilowatt hour. And that was actually a 24% improvement from 2021. And it's AWS technologies that our teams have been able to leverage that drove some of this improvement. One example is how our water teams have used simulated expected water use and compared that to the measurement and actual water use in the data centers. The expected use in the past has come from data center designs, but the team was able to incorporate weather data from a third-party source, NOAA, to improve the accuracy of expected water use. What this then allowed was that they could respond to operational inefficiencies in a more timely manner and stop water leakages, for example. Given that 2% of the global water supply is suitable for human consumption, we really need to avoid it being wasted. The EPA estimates that 1.7 trillion gallons, roughly 30% of all treated water, is wasted every year in the United States alone. For water utilities around the world, aging infrastructure is increasingly becoming a problem. To actively manage the water system, getting information like consumption, pressure, and flow data in real time is crucial. And it's architectures like this one I'm sharing, which shows you how AWS IoT Core for LoRaWAN can be used to reliably collect water meter data from meter readings from multiple sources, multiple devices in the network. This would allow you to transfer the data to the cloud, detect water leakage in the grid, and gain deeper insights into water consumption. So leveraging digital technologies to accelerate circularity requires this combination of technology and data. Doing so can create a more sustainable and efficient way of doing business. And this is what SK ecoplant has done. So to tell you more, please join with me in welcoming Mr. Kusum O to the stage.
Yeah, thank you for introducing me, Jenna. I'm Kusamo, the leader of SK ecoplant AI innovation team. I'm really grateful for presenting today and engaging in discourse on the environmental issues. In this presentation, I will explain how SK ecoplant is innovating the environmental industry and solving the environmental problems through digital technology and data. First of all, I would like to briefly introduce SK Group and SK ecoplant before delving into the main parts. SK Group is one of the largest companies in South Korea, like Samsung and Hyundai. And the revenue is $138 billion US. Also, SK Group has over 180 subsidiaries. In 2023, SK Group was ranked as the 92nd largest company in the world by Fortune. SK Group focuses on 4 key areas: advanced materials, digital, green, and biopharmaceutical. Among these, SK ecoplant, where I work, plays a pivotal role in the green sector. If you think about the circular economy, it basically means that waste is not discarded, but rather returned to the energy or resources. If you take a closer look at the entire waste life cycle, we can see that many companies are discussing the concept of a circular economy. However, it is important to note these companies are still managing waste in a traditional way, without utilizing any advanced technologies. The environmental industry still has a lot of work done by manual process and phone communication. Simply, there's no integrated system. Companies in this area also concentrate on each other's work, so that makes their businesses fragmented and substantially challenging to integrate with traditional ways. In this situation, let me run you through how ecoplant is solving the environmental problem to circular economy. Data and connections. We are focusing on two keywords to create a connection between fragmented environmental business. SK ecoplant collects and analyzes data for it. I will explain more about our plan. Now you can see a company in the middle. Companies play an important role in our society, but unfortunately, they are also a major problem related to carbon and waste. Our approach is measuring the amount of carbon and waste emissions by companies. On the left side, you will see a concept of our carbon management named Weibull Decarbon. The first step is measuring the amount of carbon. If these companies engage in activities that offset their carbon emissions, such as trading carbon credits, our platform will give them credits for their efforts. On the right side is the concept of our circular economy. SK ecoplant developed its own digital waste management platform named Weibull Circular. It won the CES Innovation Award in 2023, and it can help digitalize and manage the process of returning waste. Therefore, we can obtain data via Weibull that provides valuable insights into what needs to be solved and how to solve it. And it doesn't just end with that. We developed Weibull Re-Energy for incinerators and Weibull Re-Water for wastewater treatment. First, I will briefly introduce Weibull Re-Energy and Weibull Circular. And then I will explain Weibull Re-Water in detail. Weibull Re-Energy is a solution that increases efficiency and reduces pollutants of existing incinerators. It has been applied to 5 incinerators in South Korea, resulting in 12 NOx reduction and 3% energy recovery rates increase. It is currently being applied in Southeast Asia as well. Weibull Circular is a digital waste management platform. It provides visibility and transparency. And it is currently used by over 200 companies and has reduced its effort by over 50% by simplifying the complex process. Now, let me provide you with background information of the wastewater treatment process. It will be better for your understanding. In brief, after the wastewater enters, it goes to the settling tank for sedimentation. Then it undergoes biological treatment in bioreactor, followed by chemical treatment in the disinfection process. Finally, the water is discharged. The treatment process itself is not very complex, but dealing with water is still one of the most difficult fields due to various reasons, such as the long retention time and difficulty in measuring the exact reaction. Also, there were more challenges than we initially thought. First, only the effluent water quality was being measured for regulation. And there was not much data being collected during the intermediate stages. Second, as there are no measurement and no prediction, each operation relied on the operator's experience. Moreover, since there was no prediction, excessive chemicals and biological energy were being used for the final discharge results. Third, even if sensors were installed, they were easily contaminated as wastewater continues to flow. Then they needed to be cleaned and calibrated continuously. Usually, this process needed to be done once every 2 months, but those who managed it were busy, and sometimes sensor cleaning was neglected, resulting in inaccurate data collection. Naturally, prediction that were forecasted using inaccurate data lost the trust of the operators, and they eventually returned to the past operation. We solved these challenges with AWS. We have equipped various sensors to enable real-time monitoring and developed a digital management platform for it. Next, we predict the effluent water quality based on the data rather than the operator's experience so that they could operate optimally. Finally, we developed AI-based software calibration to solve sensor contamination. Here is a service screen of a wearable river that I explained earlier. It consists of three main parts. Firstly, the blue area is AI guidance for airflow, which guides the amount of air injected for microorganisms. The yellow area is AI guidance for chemical flow, which guides the amount of chemicals to remove tiny particles. Lastly, the green area is AI-based water quality prediction, which forecasts the water quality 9 hours later. The AI guidance helps reduce operating costs, while water quality prediction can forecast future water quality so that it makes the operators can work optimally in advance. In particular, water quality prediction shows performance of over 85% accuracy by 1- MAP criteria. I believe that it is top level accuracy in this area. It is AI-based software calibration. As I mentioned earlier, the sensors are easily contaminated by wastewater, making it difficult to keep measuring accurate data. Due to this situation, operators do not trust the sensor data and change their operating conditions using the lab data that is only sampled once a day. AI-based software calibration is a service that collects contaminated data values using AI when the sensor data differs significantly from the lab data. As shown in the graph below, the orange line is the raw data from sensors, and green data represents the lab data. It is a kind of ground truth. When the sense is virtually calibrated by our AI, the data is collected as shown by the blue line. And it shows a distribution similar to the lab data. Through this, the reliability of the sensor can be maintained for a long time, and a maintenance period can be extended, so reducing the workload for physical calibration. Now, I would like to explain how we implemented the wearable URL with AWS. Let me tell you more technical details. SK ecoplant operates over 1,000 water treatment plants in South Korea. In the near future, we are preparing to introduce wearable URL for achieving centralized control management. I would like to explain what AWS services we used and what difficulties we overcame. The first was the CDK service. There were time and financial difficulties to deploy wearable URL from the outset. Utilizing CDK allowed us to simply modify the solution to fit each plant's unique characteristics. The second was Kinesis service. By utilizing Kinesis, a streaming data pipeline could be easily and quickly configured based on the data size. The third was the ECR service. By utilizing ECR, the model could be easily managed by version, and if necessary, it could be easily loaded back to the previous one. The fourth one is SageMaker. AWS SageMaker helps to choose the appropriate algorithms for each plans and provide various tools for easy model deployment. Next, let me explain the architecture of Weibull River. The field and weather data are collected via kinesis. When examining the area where the collected data is stored, the data is loaded into S3 low, also is then resampled and restored in S3 gold. Our AI model is then trained and deployed using S3 gold. Also, the code is stored by commit in code commit. Looking at the model inference process, AWS Lambda is used. Lambda brings real-time data to the VPC and stores data in InfluxDB. Then, using the model, it infers the water quality prediction values. Now, let's take a closer look at some of the key AWS services. The first one is CI/CD data pipeline. Weibull River reused many parts from the previous developed Weibull Re-Energy that I simply introduced earlier. This is easily made possible by utilizing CDK. We plan to expand the solution to more sites by 2024. We expect to be able to easily configure new sites and make models using AWS code pipeline. When configuring CDK and code pipeline, the code is modified to reflect the characteristics of each site. Depending on characteristics, the modified code is managed by the repository in code commit. For example, when training a model in SageMaker, it manages the optimal pipe parameters found for each site. Next, I will talk about Kinesis data stream. About 5,000 types of data are collected from each site, and among these, 900 types are utilized in Weibull River via Kinesis. As Weibull River expands to more sites in the future, more real-time data processing will be required. Kinesis can easily and quickly process time series data without losing data. It is essential for Weibull River. And the most important thing is SageMaker for water quality prediction. Weibull River has a total of 9 models. For each model is simultaneously trained using SageMaker whenever retraining is required. In addition, when introducing new algorithms and hyperparameter optimization is also performed concurrently using SageMaker. As I mentioned earlier, wastewater treatment undergoes biological purification, which utilize microorganisms. Microorganisms are highly sensitive to seasonality due to the impact of their environment. Weibull River utilizes ECR to automatically manage the version of models. And if a model is trained that performs poorly for any number of reasons, such as sensor contamination and environmental changes, it can be easily rolled back to the previous version. Weibull River was developed over 1 year. It took a lot of time to get an AI model that reflects the seasonality, rather than simply setting up the system and installing the sensors. Many operators said that AI guidance and water quality prediction could provide support for optimum operation, and based on this, it could save resources. The graph on this slide is comparison of the flow power consumption during the same period last year and since Weibull River was applied. We have reduced the flow power rates by 12% compared to the previous year, which can lead to 19% reduction in power consumption. When convert them to greenhouse gas, this is the same effect as reducing GHG emissions by 13%. It is simply possible to calculate well-known formula. Additionally, although not discussed today, we have also achieved 10% reduction in usage of chemicals through AI guidance. When the automation phase used in self-driving cars is applied to wastewater treatment, most existing plants are in 1 or 2 phase. By applying our solution, they are able to operate at level 3. To achieve net zero and circular economy, we believe that they need to be controlled in a more advanced way to reduce carbon and energy consumption. For this, more digital technology is needed, and SK ecoplant will continue to develop viable rewater to secure sustainable processing technology. SK ecoplant is trying to solve many environmental problems through digital technology and data. And as I mentioned today, we have achieved huge progress in these environmental businesses. If you are interested in our solution and technology, please visit our website and contact me. Thank you for listening. Now I'll hand over back to Jenna.
What a great example. I think it's, when I first came across it and Mr. Kusum-Oh, I was so excited because it really embodies what we've spoken about today, which is what is circularity and why circularity and circular economy and transitioning to one is important, and we need to accelerate it. And the way that they have done that through technology and data, I was really impressed, and I hope you have enjoyed it today. As I said earlier, a lot of you in this room or watching online have the skills to do similar things within your own organization. So I'm going to give you all a homework assignment. Go back into your organizations and find opportunities where AWS technologies could accelerate existing circular economy initiatives, or at least start the conversation on how processes that you're aware of can be moved to be less linear and more circular, and then how technologies could accelerate those outcomes. Also, be sure to check out our other sustainability sessions scheduled this week, and there are more that you're able to watch on demand that happen earlier in the week. And myself and my colleagues, we are all at Caesars Forum at the Sustainability Showcase, both today and tomorrow. So please, if you're around, stop by. We have a lot of other examples of where technologies and data have come together to either result in sustainable outcomes or accelerate some initiatives in motion. So on behalf of Mr. Kusum-Oh and myself, I want to thank you for being part of the conversation. I hope you learned something today about circularity and why it is such an integral step to take to building a more sustainable business and a more sustainable world. And so speaking of being data-driven, we want to capture your opinion. So please take a moment to complete the session survey in the mobile app. And thank you very much, and see you next time.